And in this talk, I want to talk about resiliency against cyber attack. Okay, so this is a bit different from the resilience against natural disaster, but in the worst case, the natural disaster may be accompanied with some sort of cyber attack. Okay, the attacker want to hit us when we are at the weakest point. So in this talk, I want to talk about two most famous attacks on industrial control systems. One is Stuxnet, and the other is a recent cyber attack on Ukrainian grid. Okay, so after that, I will walk through some details of these two attacks, and after that, we will discuss what we can learn from these attacks. So the Stuxnet attack was an attack on the Iranian nuclear enrichment facilities. So this is not an attack on a grid, but this attack strategy can be adapted to attack the power grid as well. So I think it's worthwhile to look at the details, like how the attack was developed. So this attack was first discovered in 2010, but it turned out that, according to the forensic research, this attack has been running since 2007, and it hasn't been discovered for 3 years. And this is a very sophisticated attack, allegedly state-sponsored. Considering the sophistication of attack, many experts say that this is for sure supported by some nation or some state. And this is famous for the reason that it is a first cyber weapon in the history. That it is first cyber attack that targeted military facility. Okay? So to understand how the Stuxnet worked, it's helpful to know some about the centrifuge operation. So uranium enrichment facilities consist of a cascade of centrifuges. And so each cylinder here is a centrifuge, and here is the schematic of the centrifuge. So the way the centrifuge works is that, so it has a cylindrical rotor rotating very fast at tens of thousand RPM. Okay? And the UF6, which is the main ingredient for uranium enrichment, goes into the centrifuge, which is rotating very fast. Then this UF6 is converted into enriched uranium and depleted uranium. And these product gas, the uranium gas, will come out through the output pipes, okay, which is here and here. Okay, so that's how the centrifuge roughly works. And the principle of this attack was to increase the pressure on the rotor wall. Okay? By increasing the pressure of the rotor wall, it intended to damage the centrifuge. Okay? And there are two ways to increase the rotor wall pressure. One is to increase the pressure of gas in the centrifuge, the uranium gas. And the other way is to increase the speed of rotor. So Stuxnet actually has two types of attacks that were performed separately at separate time. Okay? So we will go through these two types of attacks. So the rotor speed attack is more famous one, but on the other hand, the overpressure attack is, I would say, more sophisticated attack than the other. So let's first talk about the overpressure attack. So a short summary of the overpressure attack is that the attacker compromised a Siemens controller, which controls the gas valves of the centrifuge. And then it increased the pressure of gas in the centrifuge to couch the damage of the centrifuge. So let's walk through some details. So Siemens S7-315 controller is a part of cascade protection system. So it controls the gas valves and the pressure sensors. Okay? And the attacker infected this Siemens controller, this specific Siemens controller, by delivering some malicious configuration file, probably using a USB stick. Okay? And the most probable path to infection was that the contractor goes in with infected laptop or USB stick and then plugged that into the controller. Then vendor software open the configuration file, and then it gets infected. Okay, so that is the most probable scenario that led to infection. And once this controller gets infected, then the attacker begins launching the overpressure attack. Okay, so it employs the man-in-the-middle approach. So the activation of this overpressure attack is triggered by very specific operational conditions monitored by this infected Siemens controller. And once it is triggered, then it launches the man-in-the-middle attack. Basically, the infected Siemens controller sits in the middle between the operator and centrifuges. And it sends fake sensor output to operator screen. And on the other hand, the infected controller drops legitimate control from the operator and inject malicious control to centrifuge. Okay, so that's how it works overall. So first, it replayed sensor output to system operators. So the attacker recorded the normal sensor values for 21 seconds. And it keeps replaying that 21-second interval of sensor values to the operator so that the operator will think that everything looks normal. Okay, everything is normal. So this was the SCADA screen that the operator is looking at. And during the attack, this looked totally normal to the operator. And in the meanwhile, the infected controller dropped all the legitimate control and then controlled the gas valves and pressure sensors in its own way. And the strategy was simple. So it looked at how to control the valves and basically blocked the exit passage of gases. So UF6, the ingredient, is getting into the centrifuge, but it couldn't get out during the attack. So the pressure will go up naturally. And also there are some valves that are controlled in a closed loop sense based on the pressure sensor values. And to affect these valves, the attacker deliberately basically decalibrated pressure sensors so that the pressure sensor output will look normal and it's not going to trigger the exhaust valves. So this was very intricate attack strategy. And one interesting aspect of this attack was that the attacker intentionally stopped the attack before the catastrophic destruction happens. So its intention was not to destroy the centrifuges, okay? But it's intended to achieve more sophisticated objective. Right? So some remarks about the overpressure attack is that the attack was designed in a very sophisticated way. The attacker knew what kind of gas valves were there and how to block the exit passage of gas and how they are being controlled. And also, the attack sequence was adapting to the monitored operating status of the system. And also, this attack could have been undiscovered if the attacker wanted it in that way. But this attack was, the presence of the malicious code performing this attack was accidentally discovered when the rotor speed attack was discovered later. So from this, we can guess that the truly dangerous attacks might be out there, still not being discovered to us. And also, one more aspect that I want to mention here is that here, the way that the system is infected, the contractor did a crucial role there. So even though your system might be very secure, but your contractor might be not. Okay? So the attacker leveraged this to get into the hard targets in this system. Okay? So that was overpressure attack. And then I want to talk about the other types of Stuxnet attack, which is rotor speed attack. So in this case, the attacker infected different Siemens controller, which controls the rotor drive, and then increased the rotor speed to damage the centrifuge. Okay, so the main difference from the overpressure attack is that the malicious code used for this attack was self-replicating. Okay, it replicates itself and spread it over the network, and it was also spreaded by USB sticks. So, and the malicious code used stolen certificate to pose as the legitimate driver software to the Windows system. And at the beginning, it spread it over all machines, regardless of whether it contains engineering system software or not. Later, it looked for the target Siemens controller among the machines infected. And once this Siemens controller is infected, then they again launched man-in-the-middle attack. So the legitimate control sequence is dropped by the infected Siemens controller, and then Siemens controller controlled the rotor speed as it wants. And then the SCADA sensor data was not updated. So again, the operator was blind. And the way that the rotor speed was controlled by the adversary is a bit interesting. So it didn't increase the speed just to the crazy speed like that, but it rather increased the speed from normal speed to about a third higher speed, okay, about 30% higher speed for 15 minutes, okay, from 63,000 RPM to 84,000 RPM. And then in the next 50 minutes, it decreased the RPM to almost zero, okay, almost a stop. And then that was the end of one attack cycle. And they launched this attack cycle about once per month. So in that sense, although the attacker had a capability to damage the centrifuge more drastically, but it didn't do that. It intentionally went through this specific cycle to achieve a different high-level objective. Okay, so some remarks about the rotor speed attack. So this attack had simpler design than the overpressure attack, in a sense that the attacker just needed to control the rotor speed in a certain way. It didn't have to worry about the gas valves or another complicated operation of centrifuges. And it had easier mechanism to infect machines. The code was self-replicating, but on the other hand, the code was more detectable by security experts. And so investigators think that the attacker wanted to be, almost wanted to be detected for a certain region. And that was part of the objective of the attack as well. And so, for instance, the way that the rotor speed changes, such drastic speed change may create huge sound on the floor. So even the staff might be able to listen to the sound and see something is going wrong. Okay? So hiding was not the purpose of this attack. So the purpose was more sophisticated, high-level objective. Okay? So that was the Stuxnet attack. And then now let's move on to the recent attack on Ukrainian grid. The first attack on Ukrainian grid was launched in December of 2015. And then, after a year, another attack was launched on the Ukrainian grid again. And so I consider this attack still ongoing. So basically, the same set of malicious codes that attacked the Ukrainian grid is being used over and over again, not just on the power grid, but also on railroads or other infrastructure system. Okay? And recently, cybersecurity firms analyzed those malicious codes, and they said that these codes can be easily adapted to attack critical infrastructures in US as well. Okay? So, and this was the news came out in June, this June. Okay, so let me talk about the Ukrainian attack. So it happened around 4 p.m. in December 23rd of 2015. The target of the attack was distribution networks, okay, not at the transmission level, but distribution level. And it disconnected about 30 distribution substations for 3 hours, and three distribution utilities, and about 250,000 people were affected. So in terms of the scale is not that large compared to other historic blackouts. But this blackout got huge attention due to the fact that this is the first blackout caused by a cyber attack. Okay? So in this talk, I will use the ICS, the Industrial Control System, cyber kill chain, to describe how this attack was developed and launched. Okay, this is developed by the security company SANS, and they followed the concept from military to adapt to the cyber attack. So we'll walk through the details, but at this stage, I want to mention that the attacker used diverse types of attack tools. Okay, for instance, they used spear phishing, basically emails, and also they used malicious code called Black Energy 3, and they compromised the VPN access. and they used malicious firmware. Okay, and also they used the telephonic denial of service attacks, and so many different kinds of attack tools all together in a very coordinated way. So this is very sophisticated attack again. Right? So the first stage of this kill chain is intrusion. So in this stage, the attacker's objective is to gain enough access to the system and also gain enough knowledge about the system. Okay, so it starts with a reconnaissance stage. So the investigator of this attack believes that the attacker spent enough time on selecting proper target utilities. Especially, they believe that the target utility companies were selected due to the high level of automation they have. And then after that, after the target is selected, they weaponized the Microsoft Excel and Word documents by embedding the malicious code called Black Energy 3 as a macro of that document. And then they delivered it to employees. And employees opened, and those emails are disguised as being sent from legitimate senders, of course. And then they opened this Microsoft document, and as usual, they enabled macros. And then that triggers installation of this malicious code, Black Energy 3. And then once this Black Energy 3 is installed, then they connect to the attacker's server. Then now the attacker can talk to the infected machines. And the investigators believe that it happened 6 months before the actual attack. Once this stage is done, Black Energy 3 is successfully installed, then they take actions to harvest the credentials and elevate their privileges in the system. They gained many access information, passcode, ID, and identify VPN connections. Okay, and they also identify how to get into the industrial control system network from the IT network. So they were able to figure out how to do that using the VPN access and remote admin tools in workstation at the utility control center. And then also they used the obtained credentials to gain the information about the system, how these systems works, what kind of vendor software they are using, and this kind of all information was gathered at this stage. And the next stage is ICS attack. So in ICS attack, the first stage is they develop the attack strategies and also additional attack tools based on the information they gathered in the first stage. And then also the investigators believe that they tested this attack prior to actual deployment on their own network. Considering the sophistication of this attack, that's very probable. And then they delivered themselves into the position where they can interact directly with the field component, this ICS component. Okay? And for that, they compromised human-machine interface of SCADA systems. So in the target systems, they had 2 human-machine interfaces to SCADA. One is the VPN access. So some authorized users were able to access SCADA system by establishing VPN connection. Also, the workstation in the utility control center had the remote admin tool, such as the one offered by the Windows OS. So the attacker store the credentials like passcode and ID for those connections and basically compromised these HMIs of SCADA. And that's the way they hijacked the SCADA system of utilities. Okay, and then they installed additional malicious tools such as kill disk, and then they began taking control of the workstations. Finally, they execute the attack. The primary attack was to use the compromised HMIs of SCADA system to open the breakers, about 30-some breakers, and disconnected the distribution substations. So this was primary attack, and according to the interview, the operator was able to see that the cursor was moving on the screen and clicking, disconnecting breakers here, because they were using this remote admin tool. So, and this attack the primary attack was followed by a set of supporting attacks. followed by scheduled disconnect of uninterruptible power supplies for control center. Also, they launched the telephonic DOS attack, denial of service attack, so that the affected customers cannot connect with utility companies. And they uploaded malicious firmware to the serial to Ethernet gateway device. And this is meant to basically burn down the bridge. So by doing this, even after the workstations at control center is restored, they cannot talk to the field devices, because basically the bridge was burnt down by this portion of the attack. And the kill disk installed, they wiped out data from workstation and HMI cards and servers. So these last two attacks was basically meant to delay the mitigation effort, hamper the mitigation effort of defending side. So some remarks about this attack on Ukrainian grid. It's very sophisticated attack. A lot of attack tools were used, but none of them was directly used to cause blackout. But they just did their part in the entire attack. Also, they spent about 6 months to learn about the system. It's considerable amount of time. And they were knowledgeable about the vendor system that are being used in the utilities. And I think they will be able to know that in the future, because we have a whole lot of information about the vendor systems available in the internet. So there is limited combination of vendor system that can be used in the utilities. And they can even replicate small test bed for the utility SCADA system. Also, they exploited the automated nature of this distribution management systems. So this tells us that the automation can provide more opportunities to the attacker. Okay? And unless it's followed by proper countermeasure to defend. So now what we can learn from these attacks is that some steps could have been prevented if we had some stronger security measure. Okay, for instance, the infection through contractor devices. This can be prevented by properly training the contractors or strengthen the security protocol. And also spear phishing email can be prevented by user training or whitelisting. Also VPN access, we can make the authentication protocol more rigorous by introducing, for instance, two-factor authentication. So instead of asking ID and passcode, we can ask for additional information from the user to strengthen the authentication protocol. Okay, and workstation remote access, it's best to disable any remote access unless it's really, really needed, basically. Okay, it can open a gate for the attacker. And automated control, in this attack case, one workstation was able to control everything about the grid. And that can be quite bad. So one suggestion is to have area of responsibility. So one workstation have responsible area so that when it is compromised, then it can affect, only the portion of the grid will be affected by the attack. And there are other security recommendations that is categorized based on the architecture side or passive defense, monitoring, and active defense. But I think I want to go ahead and talk about maybe more general recommendation and general remarks about this kind of attacks. So one thing is that the potential attack, adversary can be very powerful. So it's not like some random hacker throwing out some malware into your system, and then it does some small things. But now what we saw here is that it is state-sponsored adversary. Okay? They will be very well-funded and very target-oriented and focused. It can be a military operation. And if they pick your system as their target, and then they will customize their attack for your system in a very focused way. So we shouldn't neglect the power of the adversary. And in terms of the preparation for this kind of attack, I want to mention this roadmap provided by the DOE report. Okay, so DOE provided this roadmap to achieve energy delivery systems cybersecurity. In this document, they categorize potential efforts into five areas. The first one is to build a culture of security. And this encompasses many aspects. The first one is we need to train the employees in a proper way so that we can prevent spear phishing or those kind of or contractor problem in a proper way. And also this first category also encompasses that we need to take effort to, like when you introduce new technologies for power system, then we need to also think about its implication on cybersecurity as well. Okay? For instance, phasor measurement units, it's very nice technology, but it may have some implication on cybersecurity. It may introduce some additional vulnerability. Okay? And we need to continuously monitor and assess the risk in cybersecurity, and we need to develop protective measures to reduce the risk. And if the cyber attack happens, then we need a way to mitigate the impact of this attack. Lastly, the attacker evolves. Okay? They will come up with better attack strategies every time. So we need to keep improving our security. Okay? So we need to sustain the security improvement in that way. So I want to end this talk by introducing a few references on Stuxnet and the Ukrainian grid attack. Those three are very good references to those attacks. And this reference here from NESCOR is actually providing more than 40 scenarios how the modern power systems can be attacked by some cyber adversaries. So this can give you a very good idea about what are the vulnerabilities of modern power systems. And I want to briefly introduce about the CREDIC, which is Cyber Resilient Energy Delivery Consortium. So this is a consortium consisting of university and national labs. And the major objective of this consortium is to connect with industry and basically realize the technology transfer and make things happen in real world. So you can visit the CREDIC website there, and then there are many researchers very enthusiastic in working with industry people to make things happen. And yeah, so that's, I think, pretty much it I can say, and I want to open up for any questions.